Welcome to Bot Thoughts by AmtocSoft. I am Alex. At 3:14 in the morning on a Tuesday, I got paged because our deployment agent had spent 40 minutes fixing a failing migration. It had not fixed anything. It had run the same alter table statement 11 times, each time getting the same lock timeout error, each time deciding the right move was to try again with a slightly reworded SQL comment. The model was not broken. Every single step it took was locally reasonable. The system around it had no concept of you have already tried this, and it did not work, so it cheerfully kept going, convinced that attempt 11 would be different. We measured roughly 80,000 wasted tokens on a task that never moved an inch. That night taught me the thing this episode is about. A smart model is not the same as a reliable agent. Let me name the gap precisely, because it is easy to misunderstand what it means and what it does not mean. Datadog's 2026 State of AI Engineering Survey puts frontier models at around 87% on SWE Bench verified. That is a meaningful benchmark. It measures whether a model can identify and implement a fix for a real GitHub issue in a real codebase. 87% is impressive. That number does not mean the agent works at 3 in the morning under production load. SWE Bench measures a single task completion in a controlled environment, evaluated by a human reviewer. It does not measure what happens when the agent runs unattended for 40 minutes and the task fails repeatedly in the same way. It does not measure token spend, retry behavior, loop detection, or structured escalation. It measures the model's capability on a clean task. It does not measure the system's reliability on a messy production workflow. The DEV and AI Agent Reliability Reporting frames 2026 as the year the tooling for closing this gap finally caught up. Retry management, circuit breakers, audit logging, token budgets, all of these existed in distributed systems engineering for 20 years before AI agents existed. We are now applying them to the model layer, and that application is the defining engineering problem of this generation of AI agents. Not picking the smarter model. The scaffolding you wrap around the model. Let me walk the Tuesday night story more slowly, because the failure mode is subtle, and it is the failure mode that benchmarks do not catch. The migration agent had a task: apply a schema change to a production database. It ran the alter table statement. The statement hit a lock timeout, a table lock held by a long-running query. The agent received a lock timeout error message. It decided that the right response to a transient lock timeout error was to retry. That is a locally reasonable decision. Lock timeouts are often transient. It retried, same error. It looked at the error again, decided that perhaps the SQL syntax could be improved, and rewrote the statement with a slightly different comment in the SQL body. Same lock timeout. It tried again, and again. 11 times over 40 minutes, each attempt with marginally different phrasing in the SQL comment, each attempt producing the same lock timeout error. Every single decision the model made was defensible in isolation. Retry on transient errors, reasonable. Try slight variations when a retry fails, reasonable. Interpret the error as potentially related to syntax, debatable but not insane. What the agent never did was notice that it had taken the same action, in the same context, with the same result, 11 times in a row. The loop was invisible to the model because the model had no state that said I have already done this. This is the failure mode that demos do not surface. A demo runs a task once, succeeds, and ends. This failure only appears when the agent runs unattended long enough for the failure to compound, and the human reviewer is asleep. The Guardrails playbook is 7 controls. Let me walk each one. First, idempotency keys. Every tool call should carry a unique key that identifies this specific invocation of this specific action. If the agent retries the call, the tool implementation uses the key to detect the duplicate and short circuits. It returns the result of the original call without re-executing. This is standard practice in payment systems and distributed databases. It is not standard practice in agent frameworks yet, but it should be. Second, attempt budgets. Per tool, per step, per task, pick a number. If the agent has attempted the same step 3 times, the budget is spent and the loop stops. The number should be small, 3 is usually right for transient failures. 2 is right for anything that modifies state. 1 is right for anything that cannot be undone. Third, circuit breakers. If the same failure occurs on the same tool twice in a row, trip the breaker. Do not retry. Escalate. The circuit breaker exists because attempt budgets tell you when to stop on a single tool call, but do not catch the pattern of the same tool failing repeatedly across a longer loop. The circuit breaker catches that pattern. Fourth, structured escalation. When a budget is exhausted or a breaker trips, the agent should hand off cleanly, not fail silently, not hallucinate a success. Structured escalation means a status code indicating what happened, a summary of what was tried, and an explicit statement of what is unknown. A human picking up an escalation can act on that information. A vague failure message cannot be acted on. Fifth, step deduplication. If the same toolargs pair would fire twice in the same session, refuse the second invocation. This is the control that would have stopped the Tuesday night loop. The agent cannot run the same alter table 11 times if the deduplication layer blocks the second attempt. Sixth, token budgets per task. Set a hard upper bound on tokens per task before the task starts. When the budget is reached, stop. This converts an unbounded token spend into a bounded cost envelope. The 80,000 token Tuesday night run would have a hard ceiling, and the escalation would have happened at token 200, not token 80,000. Seventh, append-only audit log. Every decision the model made, every tool call the gateway allowed, every tool response received. The log is append-only and never modified. This is what lets you debug failures without rerunning prompts. You read the log row that corresponds to the failure and understand exactly what the model saw and decided. What changes when you adopt the Guardrails playbook? The specific incident I described would not have happened. The circuit breaker would trip after attempt 2 and escalate. The pager fires at 3:15 instead of 3:14, just a minute later, but with a structured handoff. Lock timeout on migration, attempted twice, circuit open, human action required. That is actionable. A vague alert saying deployment failed is not. The cost shape of your agent changes. Token spend per task gets a hard upper bound. You stop having silent 80,000 token surprises on tasks that never completed. Your infrastructure budget becomes predictable because every task has an explicit token ceiling. Observability shifts from prompt archaeology to log reading. When an agent run fails today without these controls, the debugging workflow is: read the final output, try to reconstruct what the model was thinking, maybe rerun with different prompts and see if the behavior changes. With an append-only audit log, the workflow is: read the log row for the failure, understand exactly what the model saw at that decision point, understand what the tool returned. The failure is legible from the artifact, not inferred from re-experimentation. Your on-call posture changes. The first question after an agent incident stops being "what did the model do?", which requires prompt analysis and is slow. It becomes "did any guardrail fire?", which requires reading a structured log and is fast. The signal you are looking for in an incident shifts from model behavior to guardrail behavior. Let me close with the practical list. What to do this week, this month, and this quarter. This week, add an attempt counter to every agent loop and cap it. Pick a number 3 is usually right and ship it. Do not design the perfect retry system. Add the counter. Also this week, add a token budget per task. Same pattern. It is 2 variables and a check. Add step deduplication on the call site, a set of toolargs pairs, refuse the second occurrence. This month, add idempotency keys to every tool call. This requires changes on the tool implementation side, not just the agent side, which is why it is a month project rather than a week project. Add a circuit breaker per tool with structured escalation. Add the append-only audit log with the schema from blog 260, tool name, args hash, response summary, token count, timestamp, and the escalation field. This quarter, replay test the audit log. Write a test that replays a past agent run from the log and verifies that the behavior is reproducible. If you cannot reproduce a past run from the log is not capturing enough to be useful for debugging. Find out what is missing while you have the time to fix it, not during an incident. A model that scores 87% on SWE Bench is not the same as an agent you can run unattended at 3 in the morning. Closing that gap is not about a smarter model. It is about the loop around the model. Full Guardrails playbook, the idempotency key pattern, and the audit log schema at blog 260. Long-form walkthrough video V036. Companion shorts S158 and S159. Subscribe to Bot Thoughts. I am Alex, and I will see you next episode.